Hi students, very warm welcome to this session. This is the second problem in the second unit. This is the problem. A cantilever truss is loaded as shown in figure. Find the forces in all the members of the truss and indicate the nature. Here this is the problem. Here the truss is supported in one end and free on the other end. So we can easily understand this is the cantilever truss. Here 2 points loads 10 kilonewton and 20 kilonewton are acting C and D joint respectively. Okay, here check the dimension, the length of the trusses are given or not. Okay, here the length of the member is 3 meter, here also 3 meter, the height of the member also 3 meter. Then second, you should check whether is there any inclined member or not. If any other inclined member, just check the angle of inclination of the inclined member. Here in this problem, there is only one inclined member, but we don't know exactly what is the angle of inclination of this inclined member, right? Inclined member is the BC. So, okay. Then what we are going to do, we are going to find the angle of inclination of this inclined member. How can we find it? Just we can do like this. Okay, here we know this length of the member and also this height of the member. Like you just take the triangle BDC. Okay, just take this right angle triangle. If you want, you just better to draw like this. Okay, for your reference. Here we know the length of the member, so the 3 meter, here also 3 meter. So how can we find the angle of inclination of this member? This is theta equal to here you are going to apply the trigonometry rules. Okay, what's the trigonometry rule? That's a tan theta equal to, that's the opposite side, that is BD divided by DC. Okay, the opposite side by adjacent side. Here based upon this problem we know all these detail. What's the length of the in this member BD equal to 3 meter, and also the what's the length of the next member DC, that DC also 3 meter. So tan theta equal to 1. So how can we find the theta value from this relation? So tan inverse, that's a 1, that's a theta equal to 45 degree. Okay, this is the procedure to find the angle of inclination of this any kind of inclined member. Then what should we do? We are going to find the forces and nature of forces of every members. Here already you know the procedure. What should we do? Just we can take directly a joint, right? We can take any joint directly, there is no problem, because this is a cantilever truss. No need to find any support reaction or something else. What will you do? So first of all, draw a box like this. Just for your reference, draw the box like this. Okay, just we are going to zoom in this particular joint. So you can also write like this. Take joint C. Take joint C. After that, what will you do? Just draw the free body diagram of this particular joint. Okay, how can we draw this free body diagram? This is free body. Just you're going to zoom in this particular joint. No need to consider this thing, no need to consider this point load. Okay, just you are going to consider this joint only. Okay, so just redraw. That means you are going to draw the free body diagram of this joint C. Here one point load is acting at this joint, that's the value is 10 kilonewton. This name of this joint is C. The angle of inclination, that's a theta equal to 45 degree, just before you find the value of theta. Right, now we are going to apply all assumption over here. What's our assumption? Just our assumption is all member is tension member. Okay, all the tension member. Okay, we assume that only tension force is acting on this member. Okay, second, what should we do? Just give the name of this member. What is the name of this member? So we can give the name of this like this, PCD. Okay, PCD. P means the force, or you can, instead of P you can put the F, whatever it may be, as you wish. You can give the name. And C is represent the joint. D is where is the joint, where is the member is going. Okay, the other side of the joint. Okay, PCD. What's the name of this member? It's a PCB, this is the name of the member. This PCB member is an inclined member. I said before, every inclined member has a horizontal component as well as the vertical component. So we can mark the horizontal component and vertical component of this inclined member. Okay. So the force is acting like this. How will you give the name of this horizontal component as well as vertical component? It's a very simple, because theta is lying over here, right? Here the theta is nothing, it's the same 45 degrees, it doesn't matter. What is the name of this vertical component? PCB sine 45 degree. Why do you put the sine here? Because theta is lying over here. So we can also give the name of this horizontal component PCB cos 45 degree. Can you understand? If the theta is lying on this side, you must take this face is the cos theta, this face is the sin theta. Okay, clear? Then what is our condition? So our first condition is summation of vertical force equal to 0. Just look at there, how many numbers of vertical components are over there. Just look at there. Okay, here only, and there are two vertical components. One is the point load, and another one is the vertical component of this PCB member. Okay, just write over here. Before writing this term, you must have the clear knowledge about the sign conversion. Okay, when the forces are acting towards the upward direction, you must take the positive sign. When the force is acting towards the downward direction, you must take negative sign. If the force is acting towards the rightward direction, you must take the positive sign. If the force is acting towards the leftward direction, you must consider the negative sign. Okay, here look at here, there is only one point load which is acting towards the downward direction, so that time you can put the negative sign, right? This is our condition, right? So minus 10, one more vertical common is there, that is which is acting towards the upward direction, so we can put the positive sign. So plus PCB sine 45 degree, that is equal to 0. This is our condition. Okay, right? So how can we get the result of this PCB member? Okay, how can we solve this equation? PCB sine 45 degree equal to 10. Okay, when you bring this constant value over here, this sign may change, right? Then PCB, what's the value of PCB? 10 divided by sine 45 degree. When you calculate this term, you will get the value PCB equal to 14.14 kilonewton. So we get the positive result, right? So this positive represent that's a tension. Okay, that means our assumption is right, and also our value also right. Okay, that's this here, this positive sign represent our assumption is right. Okay, then similarly we are going to find the second condition over there. That means, what's the second condition? Summation of horizontal component equal to 0. Summation of horizontal component equal to 0. Then look at the diagram, how many numbers of horizontal components are over there. Okay, there are two horizontal components. One is the PCD, another is the PCB cos theta. Just write all horizontal components here. Then at the same time, you should take care about this unit. Okay, unit, not the unit, that's a sign conversion. Okay, here PCD member which is acting towards the left direction, so that time you must put negative sign, negative PCD. Here one more horizontal component is there, that's also acting towards the left direction. So here and here you can put the negative sign. So PCB cos 45 degree equal to 0. Here you know the value of this PCB member, right? So nothing is you are going to substitute this value over here, because just before you find the value of PCB, right? So minus PCD minus of, just better to put in bracket, 14.14 cos 45 degree, that is equal to 0. So minus PCD minus, when you multiply this term you will get the value minus 10. Okay, that is equal to 0. So minus PCD equal to plus 10. Okay, so PCD equal to, that time you get the negative sign. You may think that I get the negative result, so my calculation may wrong. That's not right. It's actually this negative sign represent that answer is right, but our assumption is wrong. What do you assume before? You assume that this member, this PCD member is a tension member, but that not right. Our assumption is wrong. This actually the compression force which is acting on this member, PCD member. Okay, so you can also write like this, compression. Okay, don't confuse that. Then take the second joint, that means this joint. For your reference, better to mark a box over here. Okay, just you are going to zoom in that particular joint, that means a joint D. Okay, write like this, take joint D, then draw the free body diagram of this joint. Okay, what's the free body diagram? This is the free body diagram of joint T. Okay, this is the point load. Okay, one point load is acting at the joint T. Okay, which is acting towards the downward direction. And what's the name of this member? Basically, you assume that all members are tension member. Okay, P D C, P D B, P T E. These are the name of this joint, and we assume that all members of tension member. Okay, no need to confuse that. I will explain clearly, because this PDC and PCD both are same. You may confuse that just before we find the value of PCD. PCD is compression member. Then what's the purpose for putting this is a tension member? Okay, because of the calculation purpose, no need to confuse that thing. I will explain clearly why do I put like this. Okay, then what's our assumption? First of all, our assumption is summation of vertical component equals 0. Okay, here look at here, how many numbers of vertical components are over there? There are two vertical components, right? One is here is a point out, and another, so this is the PDB member, right? So we can also write like this, PD which is acting towards upward direction, so no, this is a positive PDB, and the point out which is acting towards the downward direction minus 20 equal to 0. So what's the value? PDB equal to 20 kilonewton. So we get the positive result, so our assumption also right. So this member is tension member, that means this member is carrying the tension force. Okay, then second come to the point. Second assumption, summation of horizontal force equal to 0. Okay, so here two numbers of horizontal forces are acting over here. So one is the PDE and another PDC. Okay, here this PD member which is acting towards the leftward direction, so we can take the negative sign, PDE. Then PD, it's a positive, PDC which is acting towards the rightward direction, so that's why we put the positive sign, PDC equal to 0. Here we know the value of PCD or PDC, whatever it may be, minus PDE plus, you put like this, then again write like this, minus 10. Okay, if you consider this member is compression, no need to put this positive sign, directly you can put this negative sign. Okay, so no need to confuse that one. Just first of all you assume this is a tension member, after that you substitute that value with the sign. Okay, don't confuse that. Plus PDC, what's the value? Minus 10. Minus 10 equal to 0. So minus PDE minus 10 equal to 0. Minus PDE equal to 10. So PDE equal to minus 10 kilonewton. That means, again one more time I am explaining about this. this is a, we get the negative sign, negative result. That's why here this member is carrying compressive force. Okay, that means our assumption is wrong, answer is right. Okay, so PDE, this member is carrying compressive force. So here one more joint is remaining, right? Just we find the value of that means the force of this member. This member is okay. We know the value of this member. We know the value of this member, and finally we don't know the value of these two members, right? Now we are going to find the forces of these two members. Then as usual procedure, what should we do? First of all, just this is for your reference, okay? No need to confuse that. Sometime what will you do? Some people will take this 20 kilonewton pointed over here, because sometimes they think like that this force is acting on at this joint, but this member is carrying this load. That's why some people take this pointed over here. That's wrong, okay? So that's why for your reference I draw this box, okay? Just what should we do? Just redraw this diagram. That means you must draw the free body diagram of this joint, okay? Take joint B. Just draw the free body diagram of this joint. Here, so one horizontal component, here one inclined member, here also one inclined member, here one vertical member. Okay, what is it? Just give the name of this member. Is a B. This member also assume this is tension for this tension member. This is a tension member. This is a tension member. Then give the name of this member. Name of this member is PBC. What's the name of this member? PBT. Name of this member PBE. PBA. These are the name of these members, and there are two inclined members over there. Here PBC and PB also the inclined member, right? So what should we do? Then mark the horizontal component and vertical component of these inclined members. So here this theta is the 45 degree, right? This is the 45 degree. So here the theta is lying on this axis, so we can easily take this is the cos theta, this is the sin theta, right? Clear? So PBC cos 45. Name of this horizontal component is PBC sin 45 degree. And what is the horizontal component and vertical components of this inclined member? This is the angle is 45 degree, right? This angle is 45 degree. Already we know the angle of inclination, so we can also write like PBE as a cos 45 degree. This name of this horizontal PBE sin 45 degree. Okay, the based upon the angle of where the angle is lying. Okay, that's also important. Then as usual procedure, what should we do? First of all, we know the condition, right? Summation of vertical force equal to 0. Just look at there, how many numbers of horizontal forces over there? There are 1, 2, 3 forces, right? Just write like this. This PBE, okay? Better to start any one direction. Don't confuse that, okay? Maybe you can come from the clockwise direction or anti-clockwise direction, okay? That time you may not miss any number, okay? Or else you may confuse that. If you make a mess, you may confuse that, okay? So better to start from the clockwise or anti-clockwise, whatever it may. Here I start from the anti-clockwise, okay? Here's first one is minus PBE cos 45 degree. Then second, this, okay, minus, which is also acting towards the downward direction, so minus PBT. Then finally PBC cos 45 degree. Okay, you can also write like this. Do you know the value of PBE? You don't know the value of PE, so you can also write PBE cos 45 degree minus, what's the value of BD? The value of BD is 20. Okay, already you know. Here you just find the value of BD. Okay, BD equal to 20 kilonewton. Just you are going to put that value over here. Here you get the positive result, so no need to change anything. so 20. Okay, then minus means this minus. Okay, this minus PBC. What's the value of PBC? Here PCB or PBC both are same, right? So you can also write like this: 14.14 cos 45 degree, that is equal to 0. So when you calculate this term, you will get the value like this: PBE cos 45 degree minus 20 minus 10, that is equal to 0. So minus PBE cos 45 degree minus 30, that is equal to 0. Minus PBE cos 45 degree equal to 30. So minus PBE equal to 30 divided by cos 45 degree. So what's the value? PBE equal to minus 42.42 kilonewton. Here you get the negative result. So what's the solution? Our assumption is wrong, but the answer is right. So here this member is a compressive member. So the member PBE, which is carrying the compressive force. Okay, then second come to the point. What's our next condition? Summation of horizontal component equal to 0. How many numbers of horizontal components are acting over there? 1, 2, 3. Okay, I said before, better to start from any one direction, maybe clockwise or anti-clockwise. Better to start from this anti-clockwise direction. Okay, so we can also write like this: PBA, which is acting towards the leftward direction, so we can put the negative sign. PBA minus PBE sine 45 degree plus, because this horizontal component is acting towards the rightward direction, so you can also write, you can put the sign as a positive sign, sine PBC sine 45 degree equal to 0. Okay, then just substitute all values over here. Do you know the value of PBA? You don't know the value of PBA. Minus, do you know the value of PBE? Yes, you know. Just here this minus, okay, don't change the sign. Minus 42.42. what you have got from this equation, just put it over here. Okay, don't change the sign, anything. Okay, here this sign is this minus, this is minus 42.42 sine 45 plus, what's the value of PBC? 14.14 sine 45, that is equal to 0. Okay, when you calculate this equation, you may get the value like this: minus PBA plus 30, this negative into negative, that is a positive, plus 30 plus 10 equal to 0. So minus PBA equal to, plus 40 equal to 0. So minus PBA equal to minus 40. So PBA equal to 40 kilonewton. We get the positive result. So what's our condition? Our assumption is right, and also answer is right. So this member PBA is carrying 40 kilonewton tension force. Okay, that's all about this problem. Thank you for watching this video.